Hey guys, and welcome back. So we've seen how we could shoot the chains and they get attached to a coordinate in world space. Now I want this attachment to happen dynamic. I want these points to find the nearest point on the sphere and gets attached to it, and then I want them to stick to that surface. So we have our pin here, and then the next thing is I'm going to use a vellum constraint. I'm going to say attached to geometry, and this geometry is going to be the sphere. So here I'm connecting the ship or the proxy geometry of the ship, and it's doing this. Okay, I'm going to create a vellum constraint and say attached to geometry. What I want to attach is the tip. Okay, and I made a group for all the points of this sphere, and I'm specifying here in the target geometry. If I remove this, no, it's working, but I prefer to specify the points in case I wanted to be more specific about it. I can say you can only be attached to these 4 or something like that. So here we simply connect the third input and say attached to geometry. Which group we want to attach? It's the tip. And here I'm setting up some stiffness so it's very strong. It's not too loose, and we have to make sure that the rest length is 0, because if we set this higher than 1, it's not going to reach the location that we wanted it to hit. Sorry. So I'm going to copy or cut the vellum solver that we had. I'm going to connect it here, and if we hit play now, we're going to see it get attached to the nearest surface, but also follow the movement. So if I template this, we're going to see the chains gets attached, and then they get dragged along with the sphere. So what I want to do now is make some piece of cloth or to represent the ground around this, and then as the chain gets pulled up, it's going to intersect with that cloth, and I want it to do something to it. So we'll see that. Cool. So this is what I have at the moment, and I'm gonna look at the cloth piece or the ground geometry. So what I've done is I've placed a grid, and it's a uniform grid with 40 and 40. And if we template this, you'll see that it's underneath in the first frame, and then as the chain gets pulled up, it's gonna collide with the ground. So I'm going to place the geometry on top, and this is our grid. And what I want to do to this grid, or actually let's not have this yet. So I'm going to disable this node, and we're going to take a look at the result. So to merge this nicely with the existing setup, first we have to define that it's a cloth piece. So I'm just saying it's a cloth geometry, and then I'm merging both of the blue inputs together and both of the constraints together. And if I look at the setup now and hit play, we will see that it's working as we expected. Now that split, let's do this. I'm going to turn that split off, and I'm gonna change the group temporarily, and I'll explain all of this in a second. I just want to show something. Okay, so if we hit play, we should see the piece of cloth falling because of gravity, and then the wires get attached to the sphere, and they're gonna start rising and drag the ground underneath them. But they're not going to be able to break this ground. Now that's something, it's really up to you whether you want to tear the ground into 2 segments or not. I'm going to show how to do that, but this behavior already, this nice distortion and pulling, is actually really good to use to drive other things, whether it's dynamic or grain sim or particle sim or anything. Okay, so what I want to do now is I want to allow this ground piece to break in the center in an interesting way. So what I've done is I've taken the ground geo, and I rotated it and added some noise, and then used the Boolean node to cut the geometry into two pieces. So if I middle click now here and middle click here, there are two separate pieces. And let's plug this in. And in order for this to stay in space, we need to provide it with a group of points and tell it that, hey, this is something we're going to freeze, don't move it at all. So I'm simply selecting it by hand, selecting the surrounding points and grouping them into a group called group 4. I'll call this inactive. Okay, and then in the vellum cloth, under the pin, this is the initial setting of the vellum. Under the pin to animation, I'm going to say I'm going to pin inactive, and I want them stopped. I don't want them to do anything. Okay, and that's going to make sure that those will stay in world space no matter what. Okay, so we have the geometry is now cut, but because of gravity, it simply falls. So what we need to do is we need to stitch this geometry. We need to stitch and create a constraint in between the two pieces to hold them together, and then let the wire do its thing. So to stitch this, we first need to select the edge that we want to stitch. And because the geometry is overlapping on top of each other, it's hard to do that. But the great thing with the Boolean, we will get groups that tells us where the seam is. So if we select the Boolean node, we first have to make sure that both of these are surfaces, if that's what you're working with. If you're using a flat surface and you set it to solid, it's not going to give you the right result. So that needs to be always set correctly. If we scroll down, you will see that there is this AB seams, and that's where the group of the new seam is going to be stored. If I click here, you will see three edge groups, AB seams, and it has 156 selection or edges, and that we're going to use with a vellum stitch. So if we create a vellum constraint, all these are settings for the vellum node. It's always the same node. Okay, it's just different settings, and I just need the vellum constraint, which is the default. I'm going to select it's a stitch. Where is it? Stitch points. And with a stitch point, we have to select the edges we need to stitch, and it will figure out, will create the constraints. So here I have it. It's a vellum stitch, and the geometry we don't have to specify, I believe. No, we have. Sorry, we need to specify the geometry, and we don't need to specify the target geometry. You just need to specify this, and you can see already there's points created, and that's what our constraints is. And I'm gonna turn this off. I'll explain why in a second. Everything else is pretty self-explanatory. This is the resistance. This is plasticity to make it get harder the longer, the more it stretches. But it's really easy to try the settings and see how they affect the sim. Now if we hit play, we will see that the ground is gonna hold its position. The piece of cloth is gonna hold its position, and then as the wire comes up, it's going to pull this away. It's going to start opening the crack. You'll see it there, but it's never going to break. Okay, and that's a threshold we have to add, and that threshold is here under breaking. So we can say we want to break this based on the stretch distance, or stretch ratio. In our example, it's best to use distance because we don't have a lot of stress on the geometry and it's flat. So if we set that to 0.1 and hit play, it's going to get pulled, and let's see. And it broke. So it's very resistant at the moment, but that's totally up to you guys on what preference do you like, the way how you want this to behave. So if we hit play, it gets pulled up, and then it's tearing the ground. And the idea from this now is that I want to use it to drive the actual RBD sim using guided simulation or any other method if you wanted to use the point deform and deform the RBD pieces. So that's something we're going to do in the next video. Obviously we have to tweak the settings for these wires. I didn't care too much because I only need the first and last point, because when it comes off of the ground it's going to be pulled all the way, so it's not gonna matter that much. But we definitely have to tweak the settings to get this to work properly. I don't like this part. Okay, so we'll continue in the next video. Thank you guys for watching and see you in a bit.